This presentation is by Chance and Mykala Fulmar. Oh, Chance Johnson and Mykala Fulmar. Right. Alright. Physics 2K15 as asked for on this paper at the top. Bam. Alright, there we go. Date of project is 12/5/2015, Saturday. Yeah. Take one.
My hand in the way.
Project Inconvenience. It's Chance Johnson, Mykala Fulmar, with accompanied by Justin Bieber tunes. Alright, here we go. Start this off. Alright, Isaac Newton's first law of motion, also known as the law of inertia, states that an object at rest will stay at rest and an object in motion will stay in motion with the same speed and direction unless acted upon by unbalanced force. Okay, video 1. The chair hitting the couch. That represented the first law of motion by the object, chair, moving at a constant speed. I guess.
And the couch stopped it.
Yes, and then force. I guess a force acted. Object would move at a constant speed unless acted upon an opposing force or something like that. The couch would be that opposing force. That is why. That's the law of motion for the first law of motion. All right, there we go. Alright, Newton's second law of motion can be formally stated as follows. The acceleration of an object as produced by net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. Right, that is Newton's second law of motion. So for the second law of motion, that would...
Basically, the first thing that we threw of it didn't have as much mass as the second thing that we threw at the books. So
it did not cause the books to fall over the little piece of paper we threw. That is, it applies to the second law of motion. Because one mass of an object had the same, I guess, inertia, movement going forward as the second object, the can, and reacts differently. So that would be how it applies to the second law of motion. The paper wasn't heavy enough to knock the bonnets over that we used, but the can was.
stated, Newton's third law is for every action there is an equal and opposite reaction. The statement means that in every interaction there is a pair of forces acting on the two interacting objects. The size of the forces on the first object equals the size of the force on the second object.
This is Newton's third law of motion. Take 4. Okay, Mykala walking by for the third law of motion would apply because, or would be correct because she is moving forward, and then whenever she is on the treadmill, our deal would be correct, or videos would be correct because she's walking the same pace or whatever. But because the treadmill has the opposing force of the basic job of a treadmill, she isn't going forward. She's staying in one spot, but I guess with the same inertia or something. So that is why our video would be correct. Producers are Chance and Mykala. Actors, Mykala and Chance. Videographer is me, Chance. What's up? Thanks for watching, fam. Alright, now we do have one thing to add here. It's very important. It is in writing. Benton ditched us to be with his girlfriend. Pathetic. So, he was voted out of the group. On request of Mykala. Miss B, listen up. This is very important.
Since Benton ditched us, it would be very helpful if you could help us out and give us a good grade.
A really good grade.
Because Benton ditched us.
Oh, pathetic.
And I'm mad.
Very mad.
Very mad.
I sent him a middle finger emoji and he just read and sent a heart.
Same.
And I called him. So, please give us a good grade. Yeah, man, because we love physics.
Woo!
Mucho love for fucking physics.
Okay.
Mark my words.
I can't do it. I can't.
Okay, so for the second law of motion, what do you have?
What? Stop. Let me read it. That hit it.
We'll explain to you one more time then.
I don't like doing it.
Well, tell me what to say then.
Just read all of it. Yeah, like what we did.
Well, why would what we did be wrong?
I don't know.
It says it on the computer.
Ow! I do not know.
Today we have demonstrated the first, second, and third law of motion. Third law of motion.
Which one was that? Oh, the walking?
Yeah.
That could be a blooper.
Yeah. Alright. How would we describe third law of motion?
I don't know, like, the treadmill is stopping me from moving, and when I wasn't on the treadmill, then I had complete control. I don't know.
Yeah.
What was that?
I dropped the ox.
Drop socks, word.
Fire. I think I'm gonna put my password up here.
You're still videoing.
No, I'm not. Oh,
I
shit. Alright, so.
Delete it. I was like, that was so
Alright. Third law of motion would. Alright, our video of Mykala walking by and then walking onto the treadmill, or we'll get starting on the treadmill, would apply. Well, it would be correct because when she's walking, it, my toe's stuck. I would, represent. Well, she's moving, I guess. You know, every action has different effects on things around. So I guess when she's moving forward, walking, that would apply to third law of motion because she's actually moving forward. But for the other part, for it to apply on the treadmill, is she's walking the same pace, but because of the opposing force of the treadmill, I guess bringing her or keeping her from moving forward. That is how it would apply.
Junior.
Okay, alright. Okay, third law of motion would be alright, it's our representation of third law of motion is correct because Mykala walking by damn it. Would producers of this video, Chance and Mykala. Actors, Mykala and Chance. Videographer was me, Chance. Alright. Thanks for watching, fam. Mine's on 10%. I don't care none of that. Alright, and we got one more thing. This is not done yet. We got something to say here. It is in writing. Benton ditched us because